Today now we are going to see an experiment of power system laboratory 2 for ME power system engineering students. Uh, this is experiment number 9, soft computing techniques for power system problems. So the aim of this uh, experiment is to solve economic dispatch problem in a power system using particle swarm optimization technique. Here the title is any of the power system problem, but I have taken economic dispatch problem. So economic dispatch problem is one of the basic power system problem, optimization problem. That problem has been taken for this experiment. And then the soft computing technique, we have used particle swarm optimization technique. So particle swarm optimization is one of the optimization technique used with the worked in the principle of the particles, the generation of particles, and generated particles have been updated. The position and velocity of each particle has been updated, and based on the fitness the final particle is selected. So this is the overall schematic about PSO. So this technique has been applied in this problem, and the economic dispatch problem is solved, and the proper solution has been given in the below paragraphs. Now we can see software. The software used is MATLAB 2014 or any updated version we can use. Then we all know economic dispatch. Already the theory I have written in another experiment. So economic dispatch is a problem of solving the set of equations for a power system, interconnected power system. If there are n number of generating units, then we need to minimize the fuel cost with suitable constraints, maybe equality or inequality or uptime, downtime, whatever may be. So the constraints based on the constraint also we need to solve the problem. So here I have written the main problem, main program is, this is the main program written. So all the input data have been stored. See data B naught, BMN coefficient. So this is a last included case. Since in the previously we have solved lossless case, now I have solved last included case. So the BMN coefficient B naught have been known coefficient, so that has been taken. Then demand, then lower bound, upper bound, everything has been taken, and then at last I have written here out is PSO Trila vectorized F6 dash N L random 0 PDF. So this statement is this is the main statement of this main program. So this PSO Trila vectorized, this is another subprogram. There are many subprograms in this to solve this optimization subprogram. First F6. F6 is one of the subprogram. So F6 only, here we have written the program for finding the economic dispatch. Then there is one more sub function, that is for forecall. This is a function to force a vector to be a single column. So make the function to be a single column, this vector, this subprogram has been written. There is one more, there is another more subprogram is there, that is to force the vector to be in a single row. So for that and all, I have used a single subprograms. Then after that, to plot the functions, I have used a subprogram GeoPlot PSO. So we have plot with the help of this program, and then at last, this is at last I have written another subprogram, that is given the main program, right? So that subprogram, this is a subprogram. The file name is PSO Trila vectorized. So this is PSO Trila vectorized. This is the file that presently there in the main program. So this program also very important one to solve. This is a general program. So this program is already there in MATLAB for any mathematical function that can be solved by using PSO. This is a common program. So this program is available in the toolbox, or in net platform it is there. So we can download this and then we can implement here. Only thing in the main program we need to write based on our objective. So at last you execute this, all this. At last the output results for that particular problem the output is a 3-unit system. So for 3-unit system, the total load is satisfied. For power, first generated is 32.88 and second generated is 64.59 and third generated is 54.85. Then the fuel cost, total fuel cost is 1.597 into e power 3. Then the loss is 2.34 megawatt, watt has been given, taken as attained as the loss. So this is the output. So this output is effective when compared to the normal lambda iteration method. So when compared to lambda iteration method, so this method is effective and we are getting the effective results as the output. So the result of the economic research problem with and without losses was solved using a particle swarm optimization technique. So this technique can be extended to solve any type of problem. It may be a power system problem or any common problem, mathematical problem, mechanical problems, whatever may be. If the objective function is clear, then and control variable, what are the control variables to define that function? Everything if you are clear, then the same program from MATLAB toolbox, power system toolbox, you can fetch the tool same code and write and you can just like that you can paste in your workspace or somewhere in your hard disk. Then only main program you can write and then you can solve it successfully. Okay, thank you.